Okay, Algebra 1. We are going to still work with solving equations with variables on both sides. But this time in our equations, we're going to have decimals and sometimes we're going to have fractions. So we want to figure out some kind of a process or a procedure that we can use to make these a little more simpler or easier for us to solve. Sometimes when we see decimals or fractions, we have a tendency to wig out, but these should not really scare us. So let's look at this example 2 here that we have. We have an equation that has decimals on both sides of the equal sign. Well, since our number system is a base 10 system, if we multiply by powers of 10, we generally have decimal motion. For example, if I had the number 12, the decimal, we really never see it, it's behind the 2. But if I multiply that by 1 power of 10, I get 120. So the decimal goes from the end of the 12, moves to the right 1 base 10 place value. If I multiply 12 by 100, that's 2 powers of 10, giving me 1200. So the decimal went from behind the 12 to the right 2 base 10 place values. So we're going to use that idea to move our decimal points to the complete end of the number that we might see. That way we can simplify and solve those equations a little bit easier. Even though decimals, we should be able to do that in its decimal form anyways. Okay, I'm going to go ahead and go up here to number 1, our first example in decimals. And we can see that we have 2 terms on this left side and 2 terms on the right side. They're all in tenths. So if I would multiply each term by a power of 10, this would move our decimal to the right 1 base 10 place value. So I'm going to multiply this side of the equation, and it's going to be the whole entire thing. And remember, whatever I do to one side to keep balanced, I must do to the other. So I'm really going to distribute this 10. So 10 times 4.5x is going to give me 45x. And a positive 10 times a positive 3 4/10 gives me a positive 34. Okay, and on this side we're going to do 10 times 1.5x. So that gives me 15x. And 10 times negative 2 6/10, so that gives me 26. Okay, now the decimals looks like they've been removed, but really we've just made the equations 10 times bigger. So now we can still do what we learned yesterday. I'm going to move and combine all the variable terms on one side, one step at a time. So that'll give me 30x plus 34, and that's going to equal negative 26. And then I'm going to subtract 34 on both sides, and that'll give me 30x equals negative 60, and divide by 30 on both sides, and then I'm going to put it over here, x equals negative 2. And again, I can go back and put the negative 2, sub it in for the x in the original problem, and check both sides. Okay, let's do one more with a decimal in it. Notice over here we have a distributive property problem, and we also have decimals. So let's do order of operations. If I target inside the parentheses first, and we've talked about we cannot combine those since they're not like terms. This doesn't have a p. So this parentheses is going to mean multiplication instead. I'm going to distribute the 6. So 6 times 1 3/10 is going to be 7 8/10, and p, excuse me. And 6 times negative 3 is negative 18. I'm going to go ahead and bring down the right-hand side of the equal because we still have tenths here and tenths here, and we only evaluated the distributive property. Okay, the next thing I'm going to do is I'm going to multiply both sides of the equation by 1 power 10. And the reason why it's only 1 power of 10 is because I see tenths. Now, if I were to see tenths and hundredths, I would multiply by 100, the bigger one. So that way it moves all the decimals all the way over. Okay, so let's distribute this 10. So here I would have 78p, and negative 180, because 10 times 18 is 180. This is going to equal 26p minus 50. Okay, then I'm going to combine my like terms. I'm going to do the variable terms first. And this would give me 52p's minus 80 is negative 50. Add 180 to both sides. And I get 52p equals 130. And if I divide by 52 on both sides, p is going to be equal to, well, let's see, I'd have to figure out how many times does 130 go into 52. Well, we might want to do longhand division here if we don't have a calculator. Okay? I know that 5 can go into 13 twice. So I'm going to go ahead and put in a 2. 2 times 2 is 4, and 2 times 5 is 10. And then if I subtract, here I get 26. And then I'm going to bring down a decimal and put the decimal there. 52 goes into 260. I'm going to go ahead and try 5 times, and that's 260. So therefore, 130 divided by 52, p equals 2.5. Okay, now let's look down here at something just a little bit different. We're going to look at changing rational coefficients into integers. Notice I've got all these rational or fraction numbers. And sometimes that can get a little, alarming for us, but it really shouldn't. But one way to easily solve this problem is, how do we undo the fraction? We really can't throw it away, but can we multiply these equations by some number that'll make these rational numbers turn into positive or negative numbers or integers? Well, the strategy here is I'm going to look at the denominator of all these fractions. And my denominators here are 2 and 3. So what I want to do is multiply each side of the equation by the least common denominator. So the least common denominator between 2 and 3 is 6. So I'm going to take 6 times 1/2 x plus 2/3. And I'm going to also do 6 times 1/3 x minus 3/2. So basically we're distributing the 6, and I'm going to go ahead and make that 6 over 1 times 1/2 x. And it's a positive 6 over 1 times 2/3. And that's 6 over 1 times 1/3 x, and a positive 6 over 1 times negative 3/2. Now look what happens when we do that. Here I can cross simplify. So half of 6, that gives me 3x. Look at the fraction is nicely been simplified. Here I can cross simplify, divide those by 3, and that gives me positive 4. That equals, well, this simplifies out to 2x, and this one simplifies out to negative 9. And again, that shows us that we really need to be able to do our fractions here in Algebra 1. So now I can combine my like variable terms and go ahead and simplify. And look how much easier and nicer that is to solve once we remove the rationals. Okay, one more. Let's look at number 2. Here we have distributive properties, so similarly like the one that we had for decimals, let's distribute order of operations first. So I'm going to distribute the 1/4. That gives me 9/4 minus 2/4 x, and that equals 3/8 x plus 4/8. Okay, now look at my denominators. Here I have 8s and 4s. So I'm going to multiply everything by the least common denominator, which would be 8. So 8 over 1 times 9 over 4, and then positive 8 over 1 times negative 2/4 x. That's going to be the same as 8 over 1 times 3/8 x, and positive 8 over 1 times 4/8. Okay, now Let's cross simplify these here, and this would give me 2 times 9. And then here I cross simplify the 4, and this would be 2 times negative 2x, which is negative 4x. On the right side, the 8's cross simplify, leaving 3x. And again, the 8's simplify out, giving me positive 4. That looks so much nicer. Okay, now let's combine our variable terms. Now, see, this is a positive 3 and this is a negative 4. What I generally like to do is move the variable term that has the smaller coefficient. That way we can avoid working with a bunch of negatives. But we really can move either one. If you're weak at negatives, I would probably move the lower coefficient until you get better at negatives, and then you can do either one just as easy. So I'm going to add 4x to both sides. And over here, I'm going to get positive 18 is 7x plus 4. Okay, and then I need to subtract 4 on both sides, and that'll give me 14 equals 7x. Let me move this up for you a little bit. That way you can see it better. Sorry. And then I'm going to divide each side by 7, and 2 equals x. Okay, so I hope you kind of grasp the concept or the idea that we are going to use with the decimals and the fractions. Be prepared to come to class tomorrow with any questions that you may have in order to clear up what your confusions may be so that you can be successful at the practice that we'll do in class.